This is Datalog Computer Educational Institute. I remain your tutor on the Introduction to SPSS Part 2. And this is session 5. We have done session 1, 2, 3, 4. In case you have not watched the session 1 to 4, you can just subscribe on our YouTube page at Datalog Institute. In this session, we'll be looking at constructing new variable, graphics, statistical inference in SPSS, and continuous outcome measures. That is what this part 2 is all about. Let's see what we'll be looking at in this session. What is expected of us. At the end of this session, of this lesson, the student should be able to know the following. Under graphics, you should be able to plot a bar chart, an histogram, a scatter plot, plotting a regression line on a scatter plot, and also do some statistical inference in SPSS. SPSS will produce good quality high resolution statistical graphics. We will look at the bar chart, histograms, and scatter plots with regression lines directly from the data. Please note that sometimes it is easier in Excel to create bar chart using the frequency. Very easier, and it's even more colorful. Bar chart can only be produced for categorical variable, e.g., ever smoke asthma, and ever smoke asthma type of variable that are categorized as smoke, ex-smoker, current smoker, and never smoke. So we categorize it into 3. So you can use it to also produce a bar chart, which is what we are going to be doing. And the process is you click on graphs, a legacy dialogues, then bar, and the following screen appears. This is what you should expect when you go through this process. When you go to bar chart and you click graphs, legacy, dialogues, then bar, and the following screen will appear. Let us click that and you see. So to have your chart, I said you will click on graphs. When you click on graphs, I said you will click on legacy dialog. You see, when you click on legacy dialog, then you click on bar. So this is the screen that you apply. You have simple, you have clustered, and you have stored. After that has been done, you click on simple and then divine, and the next screen will appear. Click number of cases, then move your choosing variable from the left hand list to the categorical axis and press OK. Okay, we click simple, we say divine, we've clicked our divine, then we move it to categorical axis. Let us deal with a exposure. Let us deal with a value that's talking about ever smoke. Have you ever smoked type of data. You see, I drag this time around. There are so many ways of doing it. You can click on it, then move by pressing this arrow. At the same time, you can click and drag it to where you want it to be run. You see, it's still the same thing. Then I press OK. Then the output window comes up immediately. Then we have our beautiful bar chart. We have our simple bar chart. It's loading. Actually, it does not usually take much time like this to load. You will see below here running graph. Here comes our beautiful bar chart. Have you ever smoked? So this is our bar chart. This is our bar chart I've just run. Now you have never smoked and you have current smoker. You see by the number of by the height of this column, you show that there's a high rate. The current smoker are more than the never smoke and also more than the ex-smoker. So that has been done for us. Let's proceed to the next video. Histogram. At this point, it is a good idea to return the select cases back to all data. By data, select cases, then all cases, followed by OK. Now at this point, it's a good idea to return the select cases back to all data. By data, select all cases, then all cases followed by OK. Histogram are produced for interval variable. Interval variable. Like age. Like age is an interval variable because you have a very long of age, different type of age. So the best chart that you can use, the best data that you can use, the best tools that you can use to pilot is to use histogram for that kind of a data. So anytime you have a interval type data, interval type variable on your work, you use histogram. Like age is the best type of variable that we plot with histogram. It's the best type of variable that you plot with histogram. So histogram are produced by interval variable GA. To produce histogram, click on graphs, legacy dialogues, then histogram, and the following screen appears. Following screen appears. To plot our histogram, go to graph, legacy. This is histogram down here. Click on histogram. Now age, the interview, we press OK. You see, these are beautiful histogram. As I say, it's the best. You see, it shows the age. Very beautiful way today. Very beautiful graph. Age at the interview, giving us the mean age, the standard deviation of the age, and also the number of patients. The number of patients that was used in this study is 130. See, that is the N, population used for the study. So we have gone through that process, and in fact, one of the things we can do is we can also run another thing. Like here I said, click on the required variable in this case, FEV in the left hand side list, and then press OK. I'm like saying that okay, to produce a histogram, click on graphs. Like now we want to plot another one for measure FEV. We are still on histogram, and there's an option there that is showing display normal curve. So which means that you can display a normal curve with your histogram chart, showing how normal the curve is. So we can try that out, and this is what is expected of us. This is what we should see when we try it out. Let us go through our SPSS window. Let's go to our SPSS window. Okay, we click graph, legacy dialog, histogram. We want to reset, or let us reset here to return that data. Now let us put FEV. Okay, then show FEV. Then we want to display histogram. Then press OK. This, as you see, the mean measure is 3.79. The standard deviation is 0.739. The population still remain 136. You see how beautiful that histogram is with the measure curve. Let's go back and explore more. Now, scatter plots. Scatter plot shows the joint behavior of two intervals variables. If you want to decide whether two interval variables are related in any way, you should first draw a scatter plot. You see, very beautiful. You can know if a particular data is related to each other in one way or the other. If you don't want to be judgmental with your decision by trying to assume that with the kind of data we collect, or I think this variable should be related to each other, the best thing that you can use to judge is to use a scatter plot graph. When you plot a scatter graph, from there you can see if there's any relationship. So how are we going to do that? We go through the same way. You go to graph, go to legacy dialogues, go to scatter slash dot, and you see all this displaying. This is the first thing that you will see when you click the scatter dot. Simple dot, matrix scatter, overlay scatter, 3D scatter. But for now, you start with simple. So what are we going to do? We want to test if the FEV ratio and the number of years smoke and exposure group. We want to see how exposure to dust and the number of years they have smoked and the FEV ratio are related to each other. Let's go and try that. Okay, graphs, legacy dialog, scatter dot. We click on simple and we define. See this beautiful chart. You see our beautiful chart here. So our y-axis, we want to put FEV ratio on our y-axis. On the x-axis, we want to put number of years smoke. Number of years smoke. Number of year smokes. Okay, these are number of years smoke. Then set by markers. That is what we want to use to set the markers for this value. So the best kind of value we can use is categorical variable, and that is why we want to use have you ever smoked, or we want to use exposure group. Let's use exposure group. We want to set it by the marker exposure group. So press OK. Press OK. Then we are good to go. So this is our data. Here you see unexposed are the blue dotted lines. The green is exposure to dust. And there is very beautiful scatter diagram. Very beautiful. From there you can know if there's any relationship. At some stages they look like there are relationship, but down towards this area here, the relationship has not much. That means towards 30 to 50, you see there is a low level in relationship between exposure group and unexposed group. But from 0 to 20, when you look up by the FEV ratio, you see like the jam packed together, which means that there's some level of relationship by age. You can see. So it's really telling us more about our variable. It's telling us more about our variable. Now, plotting a regression line on a scatter plot. Plotting a regression line on a scatter plot. To fit a line of regression, double left click on the graph. This moves the graph into the chart editor. A regression line can be added by clicking on element, then fit line total. If you have not defined any marker or fit line subgroup, if you have defined markers, this produces the following graph. Because we have defined a marker and we said our marker is exposure group, we use exposure as a marker. So because we have defined a marker, then we have no issues here. So we just go and try that out. Just go and try that. Okay, here we go. Let's go to our output. We already plot the data. We've already plotted the graph rather. You click on output, then we double click on the graph to take us to the chart editor. Okay, this is our chart editor. Okay, now here we have our chart editor. We click on elements, then say show fit line at total. Do you see that? Fit line at total. So the first thing we did is I said fit line at total. Then you see that your graph has an equation. You see, you have the equation. Let's say you are dealing with a modeling type of data. You have an equation there, but we didn't have such things. We are not doing any modeling, so we are expected to fit line at subgroup. So let us undo that. Okay, here element fit line at subgroup. So do you see that this is the line at subgroup? So you have two lines there now. You see the categories, the exposure groups. You see how beautiful our chart is. You can collapse this. See the lines. You can add less. You can select the kind of color you want. You can also increase the chart size. You can also change your. You can even see the variable. You see, you can look more at the variable here. Just cancel that out. So this is our beautiful chart. These are beautiful. You see, add fit. This is also the option for that. Add fit line at subgroup, add fit line at total. Here you have add interpolation line. So as this data label mode, show data labels, show error bars. These are any other options. Then when you are done, you close. You are done, you close. So this is our chart. These are beautiful. These are beautiful charts. These are beautiful charts. Now, the next thing we want to do now is statistical inference in SPSS. That is making a statistical inference to your work. This part we introduce the basic method of statistical inference available in SPSS. It will assume some familiarity with concepts in statistical inference, including hypothesis testing, confidence interval. This is where most of us want to get very into, like, yes, yes, yes. Now, if you are unfamiliar with this concept, you are strongly recommended to read an introductory test in medical statistics, such as Campbell and Mahin, Medical Statistics, a Common Sense Approach, just to widen your understanding. The methods will be illustrated by the Foundry data set. You already have that. That was considered in part 1. The purpose of this study was to examine whether dust increase respiratory morbidity. In this study, the measure of respiratory morbidity are ever had asthma, ever had bronchitis, measure LVV, and measure LVC. The variable predicted LVV and predicted LVC are the values that are expected for a person's demographics characteristics, including age, height, and sex. That is according to the study. Exposure to dust is measured by two variables, exposed or unexposed, and dust level recorded only for exposed workers, because smoking is a confounding factor in this study. Smoking behavior has been recorded in terms of current smoking status, smoke now, smoking history, that is smoke ever, and consumption, cigarette number. I'm trying to introduce us to our data now, and duration of smoking, which we use the IGYE, that is years. Now, categorical variable. In the first part of the study, we examine whether there was any relationship between exposure to dust and smoking. Using the cross tabulation procedure, we generate this table. From the table above, it can be seen that the percentage of workers who currently smoke is higher for those exposed to dust than those who are not, 47% as compared to 32%. You see, I'm introducing us to interpreting our data. Now, we will now examine whether respiratory symptoms as measured by variable asthma related to smoking. Using cross-tab procedure, again, we obtain the following table. Let us do that. We want to do what? We want to examine whether respiratory symptoms as measured by variable asthma related to smoking using cross-tabulation procedure. Again, let us do that. That is, we want to generate a cross-tabulation of ever had asthma and do you smoke now. Okay? To do that, I can hear someone is telling me that, okay, I cannot remember. Oh, okay, you go to descriptive, then from descriptive, I will see a cross tabulation. Yes, you are right. So we click analyze, descriptive statistics, or you see your cross tab below. Okay, cross tab, beautiful. Then what do we want to put on column? What do we want to put on row? So we want to put exposure group on the row, or either way round. Let's put exposure group on the column and ever add asthma on the row. Ever add asthma. Okay, sometime you may not know the variable, just over on it. This is ever add asthma. Beautiful. Then plus okay. You see, I run that variable based on count. I didn't add percentage. So let me rerun and put a percentage. I know some of us must have forgotten how to add percentage. You go back to descriptives, you click on cross tabulation, then you go to cell. You see the data is still here because I just left now. So unless I reset, the data will still be there, but I still need the data. So I just go to cell, and this percentage is here. So I want the percentages to show by column, then continue. Okay, now I have my new table. Now if I want to know if asthma is a factor or not a factor by using exposure group, you see here I have exposure. You see unexposed that did not have asthma are 93.7%. Exposure to dust, we have 90.4% that never had asthma. So you see, you'll be like, this is looking confusing. So does that mean that, okay, you see, this person is being exposed to dust 90.4%, but he never had asthma. Now here, this guy already had asthma before, but is unexposed to dust. 6.3% are unexposed to dust. Here you have 9.6% exposed to dust. You see, somehow higher here, exposed to, you have 99.6% exposed to dust that have had asthma in the past. So that is the cross tabulation table for us. Or, okay, oh, we made a mistake. We use a wrong data. Let us go back and use do you smoke now? Do you smoke now? We use exposed to dust. Let us go and use do you smoke now data. Okay. We go to analyze, descriptive, cross tabulation. Now let us remove this. Okay, let us remove this exposure group. What are we going to put there? Do you smoke now? That is the current smoker and their level of getting asthma. That's what we really want to see. Okay, that's still click. Then we press OK. Here we go. Now we have 88.9% current smoker but never had asthma. And you have 93.9% that never smoke. You see, but they never had asthma. But you have 77 is higher of people. Is higher. Yes, 77 that never smoke and never had asthma. But here you have 48. It's somehow low. Somehow low. And here, yes, he ever had asthma. It's not smoking now, but still have it. You have it in the past. And this, yes, smoking now and has asthma. So let's continue. Now I want to explain about Chi-square test and Fisher-Essert test. Among those who currently smoke, 11.1% had experienced symptoms of asthma, while only 6.3% amongst those who did not. Does this suggest that smoking may be related to asthma, or might this difference be due to chances? That is explained by sampling variation. One way in which we can explain this is by a Chi-square test. This can be carried out by rerunning the cross-tabulation procedure, including the Chi-square statistic option as follows. In the cross-tab panel, you see an illustration in the next slide. You will select a statistic to reveal the second panel that lists possible statistic in this panel. In this panel, we have selected Chi-square. So, we are going to select Chi-square in our next adventure now. We want to see more, we are trying to get more inference about our data. Analyze, descriptive, statistic, then cross tabulation. The data is still there. Then here we go to statistics, then we click Chi-square. You see, you go to statistics for this to come out, then you click you see there are other things that you can run here. You see you have contingency coefficient, pi and Cramer's, lambda, uncertainty coefficient. What we just need is Chi-square. You also have a correlations. We don't need that now. So click continue and press OK. Here we have our data. Talking about this data now. Now, this data that we have, you see we have 0.344 exact significance in two-sided, and we have one-sided to be 0.231, and you have option B below that is flagging a level telling me that one cell 25.0% have expected count less than 5. The minimum expected count is 4. Now, the panel above gives the result of a Chi-square test of no association between asthma and smoking. Yeah, looking at what we get, no association because it's not significant. There's no flagging of any significance there. This column gives the p-value for the significant test. Firstly, it is usually recommended that you consider a two-sided rather than one-sided. A two-sided is 95%, a one-sided is 99%. So, as one of the cell has an expected count less than or equal to 5, it is recommended that we take the Fisher exact test value as our result, that is 0.344. Why do we do that? Because we have our expected count is less than or equal to 5. So that's why we take the Fisher exact test. Fisher exact test, which is 0.344. 0.344. How do I know that it's 0.344? When you trace your Fisher test straight to this, you see, this is the value, and your continuity relation do not have any significance here. Likelihood ratio do not have any value in front of it. Fisher exact test have 0.344 here, and we have expected count less than or equal to 5. So, assuming the conventional 0.005 significance level, this result is considered non-significant. In reporting result of statistical test, you are strongly recommended to give the p-value rather than just write significant or non-significant. In reporting this, we might write, there was no evidence of an association between smoking and asthma. Fisher exact p equals to 0.344. Had the expected count been greater than 5 and the k and the table greater than 2 by 2, it is suggested that you report the straightforward Chi-square test p-value if the expected count is greater than 5, but the table is a 2 by 2, then report the continuity correction p-value. Exercise for you, and which I know you will do. Using the crosstab procedure, examine whether there is a relationship between current smoking status and bronchitis symptoms. Current smoking status and bronchitis symptoms. Are the expected number greater than 5 or for all cells? Greater than 5 for all cells. Fill in the spaces and delete as appropriate in the following statement. Amongst those that currently smoke, -% had experienced symptoms of bronchitis, whereas -% of non-smoker experienced such symptoms. This was statistically significant or not significant at a 5% level using a two-tailed continuity. Corrected chi-square test with P. Exercise 2. Now use the crosstab procedure to examine the relationship between exposure to dust and symptoms of bronchitis and asthma. Record your conclusion below using either the continuity corrected chi-square or Fisher's SR test as appropriate. Anyone that do the assignment, you can test, you can send your solution to datalogtutors@gmail.com. He will surely reply you if you are correct or not. Welcome back. We have found no statistical significant relationship between exposure to dust and either asthma or bronchitis symptoms. For bronchitis symptoms, you should have obtained the following table. That is the assignment. I hope we do it. Ever had bronchitis exposure cross tabulation? Okay. To jack our brain, let me just go back and run the analysis. For some of us have done the assignment to be sure that they run it quite well. Let's go to our SPSS window. So here we are. Analyze, descriptive, cross tabulation. You click on cross tabulation. Now we want to remove this and put ever had bronchitis. Okay. Now statistic, we are okay. Chi-square, good. Continue and okay. Here we go. Now here we have our data. Here we have our data. You see, ever had bronchitis. See, we have our data. Here you see, do you smoke now? And you see, ever had bronchitis by do you smoke now? And here you have the patient that did not smoke now to be 95.1% and have ever had bronchitis. And we have patient that smoke now and have ever had bronchitis. Now looking at our table here, the chi-square test, we have Fisher SAT to be 0.010. And we have 0.0% have expected count less than 5. The minimum expected count is 5.96. But the expected count is less than 5. Computed only for a 2x2 table. So, these are data, and this is what we have here. This is what we have here. So, why is 15%, 11/73 of the exposed worker had symptoms of bronchitis and only 6%, 4/63 of non-exposed? This difference was not statistically significant at the 5% level. We have P to be 0.179. There are several explanations for this. There may be no relationship between the exposure to dust and respiratory disease. Alternatively, the study may have lacked statistical power to detect small differences. It should be noted also that only 11% of the sample reported such symptoms. Okay, actually, what I run the other time was smoking. I didn't run exposure to dust. Let us go back and pick the okay. Analyze descriptive, cross tabulation. Here I don't want this special group, then the statistics is still safe. When I click here, you see it's still chi-square. Press continue. Okay, now I have this data here. You see 0.169 exposure to dust. We have these 11 and 4. You see? So that is that we have 4 of 63. 4 of 63 unexposed, 11 of 73 exposure to dust. 11 of 73 exposure to dust. So it is very few of the number that reported that they are exposed to dust. So that's why the result is like that. You see, that's why we say 11 of 73 of the exposed worker had symptoms of bronchitis and had only 6%, 4 of 73 of non-exposed. This difference was not statistically. In fact, it's very small. So that's why we have P to be 0.179. Alternatively, the study may have lacked statistical power to detect small differences. It should be noted also that only 11%, which is 15 of 136 of the sample, reported such symptoms. So this is the end of this session. Watch the video over and over again, practice all the exercise, and before you know it, you will get used to the click and click. Thank you. See you in session 6.